right.
Thanks for joining us. We are live on One Version here, and on the camera we're filming. Why don't you let people know who you are and what you study, what you're here for?
So I'm Pedro Vieira, and I study what happens when we put together quantum mechanics and relativity. So.
You.
Yeah, I was going to say, I feel like I've been trying to figure this out for so long.
We were studying before we came.
I'm like, I'm no physicist, but I read a lot of physics books and I listen to a lot of podcasts. So my understanding is that it's like quantum mechanics and gravity and relativity don't fit together perfectly right now. So are you essentially trying to figure that out? And if so, in your own words, how?
Yeah, so that's exactly what we try to do. So, and because it's so hard, we have been trying two things to try to overcome this difficulty. So one is we take what we call a toy model. So a toy model is a theory that we use as a playground. It's not our world, I'm sorry. It's a toy. So it is similar enough that we believe that we can learn something about the real world, but we beat it to death. So we study it from all possible points of view. We try really to study this theory. So this theory would be like a toy universe that is much more symmetric than ours. Much prettier if you want, everything is more symmetric, and that makes it easier. So it's a laboratory, it's a mental gymnasium, and we go there and we study this new theory, this toy theory, from all points of view to have one example of one theory of quantum gravity where we can really understand how to put gravity and quantum mechanics together.
Is this a computer?
Might be.
No, but I'm like literally like, what is this made up? Sorry, like this world that you're studying, you're using a computer, right?
We use computers sometimes because to help us calculate, but it's not a computer. So you can imagine our theory, for example, you probably heard of the Higgs boson, right? That was discovered a few years ago. So in our universe, we have one Higgs boson, right? So the Higgs boson is a scalar. So the scalar means it's a particle that you think of the particle as like a small sphere. It's not pointing in any direction. It's like a small sphere, and that's the Higgs boson, right? Now, for example, in this toy universe that I said, how many particles like this do we have that are like small spheres that move around? We have 6.
Oh my God, okay.
So it's not our world.
Yeah.
We have 1, in this world there are 6. So it's different. Now you could think 6 is more than 1. It's more complicated, right?
Yeah.
It's going to be a mess.
Yeah.
What are you doing? Is it 1 was hard enough? Why 6? But it so turns out that you add more structure to make it more symmetric. And you start adding more particles in order to have all these symmetries, and so that the theory in the end becomes simple enough that you can study.
Wow. That's fascinating. It's honestly so fascinating, but it's like
we have 2 questions that our audience wanted us to ask all the scientists that came through today. The first was related to, given that you studied the world in a way that lots of people don't think about it, right?
The toy world.
The toy world. How does that impact your view of life and the meaning of life?
Yeah, so we indeed are not tied to this world. So the way we do research, as I was describing, so we go to this toy universe. We do it all the time. Even if we study our world, right? We don't study the trajectory of a ball, studying all the particles that hit the ball, the wind, all the factors. We ignore stuff and we simplify to get intuition and to develop intuition tools, mathematics, physics, and so on. This is more extreme. So it's not like we ignore the wind. We ignore the universe, and we come up with a new universe and say, let's study this one. But the point is that we need one example, right? We want to study quantum mechanics and gravity, and it's hard, right? So we are stuck. So let's find one example where we can really nail it down, study it in all detail, right? So it's like we become strong, we become powerful, and then we come back to the real world, and we will kill it.
But because you're looking at the world in such a unique way, though, like in your day-to-day life, how often are you thinking about these things? Like obviously there's the laws of nature, but like, does it affect your day-to-day life and how you place meaning, how you get out of bed in the morning? Like, how often do you think about this when you're just hanging out with your family or your friends?
Oh, I'm probably thinking about these toy universes all the time, probably. Sometimes I know I'm thinking about it, sometimes I don't. I'm saying this because if I go swimming, often after swimming I get some idea, oh, we could try this, we could try that. So probably I was thinking, because even though I don't know. So it does impact a lot what you do. It's often the case that these toy universes, the rules are the same as the rules in our universe. I mean, you drop something, it falls. So it's the same. It has more symmetry, but it's the same physical intuition. That's what makes it good toys, right? So if it was a toy universe where things would behave in a totally different world, yes, it would be a toy theory, but it would be a useless toy, right? It's like, it's too much of a toy. So we want a toy, but we want a useful toy.
Amazing. Well, thank you so much for spending time with us here.
Thank you.
Enjoy your evening. It was a pleasure to meet you.
Likewise.
Have a good
They're
night.
all going to come together one day. They are. And I'm going to be looking at you for the answer.